Hello and welcome back to Bill Teaches Automotive Technology. And today we're going to take a look at a component, just one component, that controls an awful lot of things on a vehicle. The horns, the starter, the headlights, the fuel pump. There's a lot of things that a relay controls. So let's jump in and take a look at them. I'll give you some diagnostic tips and hopefully help you be able to diagnose a problem with a relay or a relay controlled circuit in a nice, simple way. Here we go. So in my almost 8 years as an automotive instructor at a community college, one of the things that I see students struggling to understand how it works and diagnosing is just the common relay. Now relays, the most common ones are either 4 connector or 5 connector relays. Relays control cooling fans, they control horns, headlights, starters. There's a lot of things that automotive manufacturers do with relays. So what I want to do today is help you understand just the basics, because this is more of a DIY channel of how relays operate, and then help you to be able to diagnose really quickly if you've got a relay problem or if you have a component problem like a bad fuel pump, bad horn, or something like that. All right, so relays. This is a basic relay schematic. Now this relay could be either a 4-prong or a 5-prong relay. Now the way I've got it drawn, this is a 5-prong relay. So let's take a look at what's going on here, okay? And then once we take a quick look at the relay and what all these things are, then I'll show you a real wiring schematic, and we'll take a look at maybe diagnosing a horn problem, a really quick way of diagnosing that. Okay, so looking at this thing, if you remember from my schematics lesson, right here, this 85 that you're looking at here, this 86 that you're looking at down here on the bottom, and then over here on the top right, we've got 87, and there we go. I'll just circle it. 87, 87A, and then 30. These are all terminal numbers, okay? And they're going to correspond to, if you look on the bottom of the relay, they're going to correspond to the blades that are sticking out of the bottom of the relay, okay? So that's what you're going to be looking at there. Now, one really cool thing about relays is most relays, the vast majority of automotive relays, will have this little wiring diagram on the side of the relay or on the top of the relay. And that just helps you understand how it works. What does each terminal do? And that's going to really help you in diagnosing. So that's going to be the first tip I'm going to give you is look at the wiring diagram on the relay to understand what each leg does. So what I'm going to do, we're going to do just a quick overview of this relay. Then I'll show you the blades that would be on the bottom of the relay, and then we'll go ahead and switch to the schematic that I looked at last time, a horn schematic, and we'll take a look at the relay actually in practice, what it does. Okay, so there's going to be 2 sides to a relay. Okay, I'm going to draw a line right down the middle of it. Okay, the left side right here, check mark. Oh, I can't see the check mark. I drew it off the relay. So right here, left half is going to be what I call the control side. And it's called the control side because this component right here is basically an electromagnet. Okay, so if you remember when you were in elementary school, you maybe are still, I'm just kidding. If you wrap a coil of wire around a nail, put a 9-volt battery on each end of the wire, we just created an electromagnet, right? So what we can do with an electromagnet is, of course, we can pick things up, or in this case, we can move stuff. So if we put power on 85 and we ground 86, we just created an electromagnet. So we created a magnetic field around this part of it. We'll talk about what this other thing is in just a minute, what the rectangular part right here is. We created an electromagnet, which then will cause this switch to move to the left. Okay, so we have a low current circuit. Okay, the 85 and 86 side, the control side, it doesn't take a whole lot of current to turn on this electromagnet and make this switch move. And then we can control something high current. Starters draw a lot of current. Cooling fans draw a lot of current. AC, the air conditioning clutch draws a lot of current. So horns draw a lot of current. So we can control something that's a large current, the right-hand side, the switched side, with something that's a low current. And that keeps the contacts. Like if we didn't have a horn relay, if we let the horn button, the horn contacts be the contact for the horn, they would burn out pretty quickly because of micro arcing. So when we energize the electromagnet on the left side, it causes the switch to flip. And let's say we have power right here, and then our horn is down here, and now we have our horn operating. And that's how a relay is going to work. Now, let's take a look at, let me get rid of all my annotations here. There. Let's, still got a couple on here, don't I? And just like that. Bam, now they're gone. Okay, so let's talk about this little thing right here. What is this? On most relays, it's either going to be a diode or a resistor. So what a diode does, it will not allow current to flow in one direction, okay? Current can't flow in both directions, in other words. It can only flow in one direction. A resistor is going to soak up the voltage. So anytime we have an electromagnet, when we energize these coils right here, we create a magnetic field around that because it's an electromagnet. If, again, throw back to elementary school days, put a magnet under a clear sheet of plexiglass or whatever, sprinkle some iron filings on it, and you can see something very similar to what I just drew. Okay, now when we switch off the relay, we remove power or we remove ground, that magnetic field is going to collapse. And that's going to create something called magnetic induction. It's going to actually induce a voltage into these wires right here, which could cause a spike that will blow, that could burn out whatever device is turning on or off the control side. Most likely a computer is what does it most of the time. So you don't want a spike back to the computer to blow out your computer. All right, let me close this out. Okay. So that's what this is. This is either a relay or a diode, one of the two. And most manufacturers are going to put those in the relays to keep a spike of voltage to going back to blow the ECM or whatever to burn out the control side. Okay, now what I'm going to do now is let me show you the bottom side of the relay. So this is what the inner workings of the relay look like. Again, this diagram will either be on the side of 95% of most relays or on the top of the relay. And then on the bottom side, you've got the actual blades, which will also be annotated. They'll also have their numbers on them, just like you see here, the 87, the 86, 87A. So what that is where you see 87 up here, that's going to be 87 right here. Okay. So if this was the horn relay, okay, and we have battery power here. Oops. We have battery power right here on 87. and then 30 goes to the horns. Okay. Then if we suspect we've got a bad relay, this is really simple, y'all. Unplug the relay. Look on the bottom of the relay, find 87, find 30, and then all you have to do is look on the fuse block or wherever that relay plugs in and get a wire and jump across from 87 to 30. If your horns blow, then guess what? Everything on the switch side of that relay is doing what it's supposed to do. So we know, just based on jumpering it and the horns blow, we know that the right-hand side of that relay, the switch side, is good. Do we have a bad relay? We don't know that yet because we still have the control side of the relay that could be, we could be losing power, we could be losing ground on it, okay? So just to look at both of these together, get rid of my annotations. There. So to look at both of these together. There. So we got the up on the top side, we've got the wiring diagram. On the bottom side, we've actually got the blades, and that is, basically how what a relay looks like. Now, let's put this into practical use. Here's the wiring diagram we looked at last week. This is the horn wiring diagram. Now, right off the bat, you should be able to now recognize the horn relay. It's labeled, but also you can look at it and you can tell that this is our horn relay. It's located in the underhood fuse block. Now, it doesn't give us our terminal numbers. However, if you look at the relay itself, you'll see the wiring diagram that looks just like what I circled there on the relay, and it will have the circuit numbers on it to help you understand which one's which. Now, let's say that our horns are not blowing. Okay. First thing, super easy, check the fuse. Okay. This is our fuse. Find that fuse, check it. First thing, super easy. If the fuse is okay, what we're going to do next is we're going to get a jumper wire, look at the relay, see which terminal is this one, see which terminal is this one. And then we're going to pull it out of the underhood fuse block, and we're going to use a jumper wire to jump between these two on the fuse block, bypassing the relay. Now, if the horn blows, what's that telling us? Again, that's telling us that the switch side of the circuit is good. There's nothing wrong. We're getting power from B plus up here. It means battery power all the time. The current's going all the way through the horns, and the horns are grounded. Now, if we did not get a horn blow, then it's time to dig a little bit deeper. Are we getting power? So, based off of this wiring diagram, this is going to be a 4-prong relay. So if you flip the relay upside down, you should only see 4 blades on it. How many of those blades should have power all the time on the underhood fuse block? Now, I'm not talking about on the relay itself because we've got the relay out, we're looking at it. But on the underhood fuse block, there should be 4 female connectors that we can use the test light on. How many of those should have power? Based off of our wiring diagram, we should have 2, right? We should have one right here, and we should have one right here. So the next thing I'm going to do, once I jumper it, the horns don't blow, I'm going to check for battery power, and I should have battery power at 2 different places at the underhood fuse block. Now, if I do have power at 2 different places, then I'm going to be looking at a ground issue. Okay. I've either got this ground bad for the horns, and it looks like that's the only thing that's grounded there. Now, you could, some wiring schematics will have a hyperlink there. You could click on that, see what else is on that ground. If something else is on the ground and it works, then you know you've got a good ground. Okay, but if that's the only ground, then you find out where that ground is and you check to see if you've got a good ground or not. If the switch side is good, okay, let's say that we jumpered from here to here, the horn blew, then we've got a problem on the control side. Now, our control side, there ain't a whole lot to it, is it? Okay. So the horn blew, but with the horn button, it's still not working. Relay's not clicking when we push the horn button. I'm going to go ahead and rule out the horn switch itself down here on the bottom. Okay. So what's going to happen is when we push the horn button, it's going to send a signal to the body control module. It's going to see a ground because it's sending a slight voltage, usually 5 volts. It's not even sending a voltage. When it sees a ground right here, when we push the horn contacts, these come together. It's going to pull this circuit low, pull it to ground, and it's going to say, oh, they're trying to blow the horn. Then the body control module is going to flip this switch, grounding the relay, making the horn blow. So what you can do is and y'all, it's really rare that the BCM is bad. A lot of times it's actually the clock spring, which is just this part right here. A lot of times it's the clock spring. But okay, so if the horn's not blowing, what you can do is either grab a scan tool and command it to blow the horn, but most of you DIYers aren't going to have one of those. So you'll have to find one of these two connectors and terminals, create a ground, and then see if the relay will click and cause the horn to blow. If not, most likely your culprit is the steering wheel airbag. So I hope I gave you some good information about relays. I realize, I didn't want to get too deep because this channel is for DIYers, people that want to do stuff on their own at home. But I wanted to get you thinking about how relays work. And yes, we looked at a horn relay, but this still applies to starter relays, to fuel pump relays. Any relay you have on the vehicle, this will apply to. Most relays are either going to be 4, terminals on the relay or 5. And almost every relay will have the wiring diagram on it to help you figure out what's what. So y'all, please like and subscribe to the channel. And ask me any questions that you have in chat. Please post up your questions in chat. Are you having problems with your vehicle? Be glad to help you, diagnose something on it related to a relay or help point you in the right direction. Other than that, I'll see you next time. I've got some ideas of what I want to cover, but please hit the like and subscribe, and be sure to ask any questions you have and give me some feedback. What do you think? What would you like to see covered next time? I appreciate you. See you next time. Take care, everybody.